Hello and welcome to this construction domain session as part of the Building Smart International Summit, Marrakesh 2024. Thank you for joining. My name is Laura and I will be your moderator today. Today's session is titled Sustainability and MEP. The speakers for this session are shown on the screen, due to last up to 90 minutes, including time for question at the end. The session is being recorded and will be made available in the replay session of the event as soon as possible. Before I hand over to our speakers, I would like to remind you that this is a hybrid event. For online attendees, your microphone will remain muted for the duration of the session. If you wish to make a comment or ask a question, please use the chat box in the control panel. For the attendee here in the room, please keep the background noise to a minimum, and if you wish to make a comment or ask a question, please raise your hand and use a microphone. I would also like to bring to attention that Building Smart is committed to ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent. And standards that are developed do not favor any particular provider and are open, non-binding, and accessible to all. Please take note of our antitrust code of conduct. And now I would like to hand over to our speakers.
Good afternoon, everyone. Participate in the website and on-site. Thank you so much. And first, Ken, thank you so much. Every time you prepare me just a big stage like this. Thank you so much. Everyone, first, my name is Yash. First, I introduce myself. I have one thinking at the presentation. After the presentation, there was a colleague who called himself MEP. Being and beer sounds very similar. What I wanted to say, I like beer and I like beer. In Deutsch, beer is B-I-E-R. I think beer is building information, environmental. This is my idea. So before introduce myself, I show you my thinking. I am in Marrakesh. Beer is Riches, isn't it? Yeah. So I'm my company that I introduced. I work for the construction company that specializes in the facilities MEP construction. For the past few years at the Building Smart Summit International Summit, I've been talking about the significant contribute that MEP facility can make to the environment. In this summit, everyone talking about sustainability and impact of IC on the ecosystem. Today's presentation, it's just a program definition. There's no solution. We talk about the importance of preparing data in order to actually do environmentally friendly works. Yeah. In this presentation, I'd like to talk about how to make the data right. In the future, I'd like to communicate with everyone in each domain on the theme of how the environment can contribute to BIM works. I think important to have method to passing appropriate data to software and application to perform calculation. Is it important format data in the data society? Do you think so? 今のまであそこで OK です。Just creating a model, we cannot evolve that we have achieved the efficient in it is now possible to create accurate architecture data thanks to the advance in software. Yes. After my presentation, Professor Kyo, Mr. Kyo will analyze the data we create and present him research on how to make technical calculation easier. I think any database we can access by your web browser is useful data. Yes, there is no need to that parameter to be included the model data. I'm a businessman, so I appreciate the usefulness of being as a business tool. There's a lead and Cassidy in the building evolution program. Do you know the lead? Cassidy is only limited in Japan. Yeah. It takes a lot of time to and effort to manually enter the value into the evolution tool. Calculation result may not be accurate for the variety of some reasons. After the construction, I try to start the air conditioning machine, running, and commissioning it. Target performance may not have been achieved. Building variation calculate performance at the design stage. Rating will be low. Lose trust. It is big deal. It's right. In order to have software and application perform calculations, I think it's important to have a method of passing appropriate data. I want our evolution to be BIM data driven. For us, BIM is variable that inputs the value into the evolution tool that produce result by calculating. Using the material of the BIM model, you can enter them efficiently as possible. Receiving the result from the evolution tool, it is enough to make our work efficient. Expert BIM model. もっと前に送ってください。次。最後までちょっと、すみません、もうちょっと。もっと前に。Sorry。ごめんなさい。ずっと前です。ずっと前よね。あと、1、2、7、next. Okay. Sorry. Export your B model to IC. It connects the IC data to program 2 that evolved. MEP design stage 1 involved a lot of calculation. Our job is compare the calculation result to see if they are environmentally friendly or not. Next. This is a slide I was talking about to the special zone in law. There is I have some idea about using buildingSMART service to utilize special zone to find a way to improve some specification. I'm an air conditioner expert. It saves energy by using a special zone in air conditioning system. I thought I could design air conditioning system special zone at the coordination at the spot. When I want to air condition only a special area, calculate partial heat load. Partial heat. Yes. To provide the cooling air conditioning system according to the heat load, using special zone optimize this balance. That is what I did before. Yes. In the Valencia, I proposed the link to IHT, the exact name of the material of calculation. Next slide, please. Okay. Among the ventilation system, there is a distribution network system. Even you use the BIM data to identify construction materials. You may not be able to reach the exact product name. Of course, the quantity takeoff cannot be calculated. If you try to evaluate LCA, life cycle assessment calculation, you may have choose the wrong materials. The evolution result may not be correct. I want to be able to make accurate choice with just the air conditioning system integrate. I have been reach mapping automation. Next slide. Maybe some movie. Okay. Since I cannot identify things, I adapt what I thought about here. What I just described is what is working in the program is here. Let me have to explain this slide. Like this. Okay. I thought it's easy. This is from until now, before past my presentation, all the presentation. I want to say is that we are looking for a way to improve work efficiency using IFC. I'm always targeting and thinking about it. I want to improve efficiency with IFC. Next slide, please. Okay. Japan also working with creative BIM use case and introduce them to stakeholder. We are going to create the showing use case in the necessary to promote new things. BIM is new things. If you are interested, please refer to the homepage. After my presentation, the Professor Cho Sensei, we analyze the data we create and present him research on how to make technical calculation easier. like this. In this project, we create BIM data for actual construction, a new construction project. Data is big and heavy. I want to say is that's the data we create in the actual project. I just want to say what I'm doing to analysis to see uh, if it can use for the calculation. After my presentation, I report you only the progress of the process. It's work in the progress because as today it's not done. I'd like to give cool presentation in Singapore or Berlin or next year. We gain efficiency performing the analysis, evaluation, and simulation in the short time and with less work. The impact is that you can design the most significant MEP equipment and at the construction stage. You can choose the right MEP equipment. You can choose the most suitable waste-free MEP equipment. You can choose too hard, less waste. The result is prepare using electricity to prepare or using of energy. It's good for environment. In my experience, the reality is that we don't have time. The reality is that the calculation simple. Thinking about it, to make data by associating IC definition with methods, less wastefulness calculation. Think of it as the best power source in the world that can contribute to the low carbon. After that, you just need to, next slide please, you just need to be able to get the environment to work actually. Currently, there are many issues, and the large data is loaded on the PC. It is also important proceed with IDS and validation system. In this research, Amanda optimizing the pressure state. Next. In this research, program will optimize the pressure state of that as an analysis. It's a process of it's a process of finding issue and developing program to work with data. That's all my story. After that, the research is explained Mr. Dr. Kyo.
You could present here if you want to read a slide.
Okay. Good afternoon, everyone. I'm Leishi from Tohoku Institute of Technology. In part 2, we will show you our approach of IC visualization in MEP engineering. As the development is under construction, our presentation will focus on how to use the IC data. Next. Here is the agenda of part 2. First, I will talk about how to export IC data. Next, I will explain how to analyze the system information using IC data. We will then propose our lightweight beam system for duct design. Lastly, the conclusion will be drawn. Deficiencies in duct design significantly impact the HVAC system performance, including energy efficiency, system operating cost, and health of occupants. Notably, a poorly constructed duct system can greatly compromise energy efficiency. In part 2, we focus on the use of IC data for duct design. Next. The first thing is how to generate IC data. Commonly, BIM software such as Revit and ArchiCAD are used to export IC data. In our case study, we used Revit 2025 to generate the native BIM data. To effectively use IC data, the first and the foremost step is to correct IC export correctly. On the analysis table of Revit ribbon, the show in this disconnect option tool can be found. You can select the category to analysis. In our study, we select the duct category. For complex systems, it is recommended to assess each category separately. As shown in this figure, there is a disconnect between the diffuser and the duct. Also, there are some disconnects on the third box for supply air. We found the problems came from the family defined by the user. After solving these problems, the duct system can be checked. Then you can click a duct segment. The duct here can be highlighted. Click the system inspector here. The directions of airflow appears along the ducts. As the critical duct path has the biggest pressure loss, the color of the arrow is red. According to our experience, if you can show the arrows of the duct path, you can export IC data for duct system correctly. Next, I will talk about how to analyze the system information using IC data. From our previous study, we developed a web-based method for analysis and visualization of duct system, which is the main part of Liu's master's thesis. The focus of his study lies into two areas. First is the analysis of the ductwork. To realize the air volume at the most remote terminal, the total pressure of the system is calculated by summing up the pressure loss of each duct element. In the critical path, we proposed varied levels of critical path and nodes to depict a duct system. A duct path originates from the start point. In ventilation system, air handling unit will be the starting point of the level 1 critical path. The diverging point then becomes the start point of the next level critical path. And the diverging point is called node in our past studies. We developed a tool to visualize the 3D model and the pressure loss in the duct path. The level 1 critical path is highlighted. The pressure loss will be illustrated on the right side. The total pressure loss can be used to select the suitable fan for an air handling unit system. At the diverging fitting here, we can get a level 2 critical path. With the pressure loss here is about 62 pascals. At the level 1 path, the pressure at the fitting 99 pascals. This means there should be a damper set on this path. The second key point of his study interactive visualization between the 3D view and the pressure chart. The 3D model is shown on the left side, and the pressure distribution lines are plotted on the right side. If you click the line segment on the pressure chart, the fitting can be highlighted on the 3D model. You can also initiate the interaction process from the 3D model side. Here is the demonstration of IC pressure viewer we developed. First, open the IC file. Then the 3D model can be visualized. You can click the IC system. This is the supply air system, and this is the outside air system. And also the detailed duct element can be confirmed here. Next, click the system analysis menu. The pressure chart will be shown at the right side. If you click the duct element on the left side, and its pressure loss can be highlighted on the right side. The vertical line stands for the pressure loss of duct element, such as the fitting or equipment. And the inclined line segment stands for the pressure loss of the duct segment. The whole pressure loss for a critical path can also be visualized. You can see the interaction is realized between the left side and the right side. This vertical line stands for the pressure loss at the diffuser. Use the IC data in an existing building. We start a collaborative study with Mr. Yaj of Shinyo Corporation. In part 1, Mr. Yaj had presented us with the MEP model of Shinyo company. Next, I would like to ask Liu Yin to continue our presentation. He will talk about the lightweight method we propose and some results of our case studies.
This is the flowchart of our proposal. Here, we use blend beam add-on to analyze the exported IC data. The data are divided into two categories. One is system type, and the other is spatial structure type. The geometric information is contained in the GLTF file, and the other attribute information is exported as JSON format. Finally, we visualize the system and spatial structure data by 3JS. The file capacity of the IC file exported by the native BIM software is about 744 megabytes. By splitting the whole IC file with the capacity of 744 megabytes, we converted it into a GLTF file, 411 megabytes, and a JSON file about 67 megabytes. And it can also be divided by building story and system. For example, the file capacity of the first floor is 147 megabytes, and the second floor supply air system is about 3 megabytes. After loading the whole GLTF file, the related semantic information in the JSON format can be read at the same time. And it will take 118 seconds to load this file. Compared with InVision, it takes about 140 seconds to load this IFC file. In the beginning, a preload option is provided. As shown in the left figure, by selecting the hyperlink corresponding to the third floor, which is split by building story, only the GLTF and the JSON file for the third floor will be loaded. This approach can significantly reduce the loading time because all geometries are not loaded from the start. Here, the loading time is only about 29 seconds. Using the same method, a system model can be also loaded. As shown in the left figure, a supply air system on the second floor was selected. It can be visualized in about 1 second. And ductwork analysis can also be performed on this system. Besides, based on the current data from the model, the level 1 critical path of the system was visualized. As shown in the red path on the left figure, the detailed area is shown on the right. Similarly, the level 2 critical path was obtained from the analysis.
Next, I will go on presentation. Once the total pressure loss has been calculated, the power consumption of the farm can be estimated by referring to the performance curve of the farm. That's all our presentation. And here shows the conclusions of our presentation. In the part 2, we first show you how to correctly export the IC file. And referring to the IC4 specification, you can get the relation of the duct connection. Then we can use then we can analyze that system. And we also introduce our proposal of lightweight beam system for duct design. As the tool is now under construction, we will complete the system visualization for the whole ductwork in the Xinluo's Innovation Hub. Then we calculate the pressure loss for funds. Then the energy consumption will be predicted. Following these steps, the predict will be compared with the actual energy consumption in Xinluo's operation. We hope we can share our results at the upcoming buildingSMART Summit in Singapore. Next. Thank you very much for your attention. Thank you. That's all.
Is there any questions?
Thank you very much for doing presentation. And I have a question to Professor Zhu. And the main you've done was the export IFC from Reddit, and then divide IFC data to geometry and then some attribute, and put all those to JSON. But next is my question: how can you visualize those divided data to this kind of the visual information? Is my question.
Thank you very much. First, we use 3JS to load this GLTF file, as well as the Johnson format of attributes. Yeah.
3JS, I'm not the development site person, but anyhow, I have this keyword. But is it same as IFC.js? It's not the same technology.
It's similar, but we use 3JS for several years. And the first example, we also use 3JS to visualize that work. In the video we showed just now, it also the tool is made using 3JS.
I see. For my interest, but is it specified technology for IFC or a very general technology for creating and visualize 3D? The 3JS is which one?
We also heard about the name of IFC.js, but as far as we studied for several years, we found 3JS is more convenient to combine with the IFC data.
Also, 3JS is very general, right?
We can not only show the 3D geometric data, but we also can use the attribute data. For example, we also use the pressure chart, which is also from JavaScript file, JavaScript library, JavaScript library. So we can combine the and the attribute such like the pressure chart.
How about introducing this kind of the architecture to us inside puzzle? Because we are very interested in this kind of lightweight the visualization, and start to use BI too, such like the Power BI of the Microsoft and Tableau. So, but it's, I guess this kind of solution and that kind of the package combined with, and then we can have much more very convenient and then the data-rich dashboard. So do you have any idea to this kind of edit? Please let me know.
Yes, we also tried some method to visualize the IC data. And this time we found GLTF file format is very, very lightweight.
Yeah, thank you.
Thank you.
Thank you. I have a question. So I understand, okay, you obtain data, you run the analysis, okay? So in the analysis, you may decide to make a change in the system. Is there, then you produce then another, I don't know, XC file if you want to send back to the model, to the right model to make a correction of the new equipment or the new pipe or I don't know. Is that the process also that you do with this?
Yeah, we use the data from the native build, and we divide the IC data for system data and the spatial structure data, such as the building story. And we also calculate the pressure loss of the duct system. And this data, in the future, we can save it to the IC file, and maybe we can enrich the original IC file.
Yeah, but okay, I think maybe mostly in dimensions, the dimensions that you change, I don't know, diameter of the pipe or.
There is no change of the IC data, no change, and the figure and the 3D view of the system will not change. Maybe it is. We also compared with our results with InVision, and the 3D geometry information is the same.
Thank you.
Thanks.
I have several questions. The first one is more technical, which is I see you convert the active file into pieces of the GLTF. So I was wondering, it's possible that that we can convert all the elements in the FC to pieces of GLTF. That's the first question. The second is we see really good innovation for that design. So I'm thinking from the industry perspective, is there any company or industry already adopt our innovation? That's my question.
Okay, thank you very much. First, I think GLTF is a good format for geometry information, I think. And the second, and there are some studies about GLTF data, and we also company maybe.
3JS has a
Yeah.
3JS has a 3JS has a GLTF loader 思路 directly load the GLTF in the scene. So GLTF file, GLTF file, size is IFC, is smaller than IFC. Geometric information is saved.
Only geometry information is saved in the GLTF file, so it's very small. Yeah. And the second question of you, what's the second question of you?
Yeah, my second question is, I was wondering the connection between the university and the industry adoption. So that's the industry or some companies in the design area already use our product or use our innovation.
Nowadays, we start a collaborative study with Xinjiang Corporation. We try to develop these two, and we want to use these two on the design on the in the corporation. Yeah, I see. Thank you very much.
Yeah, to the professor, and then
Liu.
right? Yeah, that's the presentation in Valencia. You propose us and show us that the price of being sold is very high and it's a very big obstacle to get into using this software. But this kind of web-based system is not only for just the bring the costs, but there's some more the possibility to enhance it, to combine some outside data. Sometimes it's CO2 or those kind of information, and then use IoT much more some possibility, make it possible. So is there any other idea to use this technology and this MEP information combined with some information?
Yes, you are right. We also try to develop such lightweight BIM tool based on the open BIM format. Use IFC and use GLTF file. If there is a database for such as dioxide carbon emissions, we can show the dioxide carbon emissions, I think. And also we want to try to use this tool in pipe design, and also maybe in the future it can be used for electrical design. And in the MEP systems, water, air, and electrical may be the same, and the connection point is corrected, and the analysis of the whole system can be calculated, I think.
Yeah, thank you very much. I understand.